Okay, finishing up question 3 here real quick. Okay, again, the part E is just from our exam 7. Okay, we have a nonlinear equation, we have a linear equation. All right, so I'm going to go down through here. I've already solved. I found that x equals -2. I found that x equals 1. We have 2 points where this line is going to hit. So I need to make sure then that I'm graphing, and I've got my x equals -2, my x equals 1. So I'm going to plug those back into one of these equations. I'd pick the one without the squared term. It's just going to be easier to solve. I'll have a y equals -3 times, instead of an x, I'm going to plug in a -2 minus 6. So that ends up giving me a y equals a positive 6 minus 6, which gives me y equals 0. So that means that this line crosses at the point -2, 0. That's one of the points where it intersects. Then I've also got my x equals 1. So I'm going to go y equals -3 times 1 minus 6. Gives me y equals -3 minus 6. Y equals -9. So that means the point 1, -9 is also where it intersects. So these are my 2 answers to part E. Okay? Then it says draw a graph of this function and mark each of the points found. So I need to graph then all these points up above that I found. I need to graph my 2 zeros at -2, 0, and 0, 0. So I've got -2, 0, and I've got 0, 0. I need to graph my y-intercept, which right now my y-intercept's already graphed because it was the same as the x-intercept. I need to graph my vertex. My vertex is -1, 3. So -1, 3. Okay? And then I can also graph the 2 points where it intersect. Okay, the 2 points that it intersected were at -2, 0. We already got -2, 0. Then I've got 1, -9. Which is going to be right down here, 1, -9. Okay, so I can now graph this parabola. A little shaky on the left side. Okay, but I was able to graph that parabola using those points. It doesn't say anything about labeling. It's not going to hurt to label, though. That will just help you out. Maybe give you some bonus points. Okay, question 4. This is our exponential function. So question 4, the amount of electricity that a solar panel is capable of producing decays exponentially over time. After 5 years, a solar panel produces 94% of the electricity that it was able to produce when it was brand new. Our standard equation, okay, and this is probably one of the trickier ones. We're going to have to work on this a little bit. Okay, I've got y equals a times b to the x power. Okay, a is our start value. X always deals with time. X always deals with time. Our y value is going to be our amount left. Okay, and our b value is our constant, our exponential decay constant. So I guess, since the way that they're writing this in the question is, I should change that b to a k. So I'm trying to find at what rate is this thing decaying. So if I read back up on part 4, okay, it says that after 5 years, 5 years sounds like time. What's that 5 going to be? The x. A solar panel produces 94% of the electricity that it was able to produce when it was brand new. So, whatever I pick for my start value here, 94% of that is going to be left after 5 years. So what would be the easiest start value that we could pick for A? How about, well, 0 would probably be the easiest, but 0 would screw everything up. So let's try 1 for our A value. So I'm going to plug this in then. I'm going to have a 1 for my A value. We're searching for our K. I don't know what that is. And then my X that I'm looking at is I'm going to say 5 years for my X. Okay? So I've got a starting value at 1. Okay? My start value is at 1. I don't know what this rate is, but I'm going to find out here in a second. And I want to know, after 5 years, how much is left. Well, 94% of 1 is going to be left after 5 years. What's 94% of 1? Well, 94% of 1 is going to be 0.94. Okay? So 94% of 1 is left after my 5 years. Okay? So I need to solve this equation now. My goal now is I got to be able to solve this equation for k. Okay? Well, I've got 1 times k to the 5th. Is that 1 going to do anything? No. I've really got a 0.94 equals k to the 5th power. How am I going to get rid of that 5th power? Well, I have to do the opposite. And the opposite of k to the 5th power is the 5th root. So those would cancel. That means I have to do the 5th root here. So that tells me then that my k value, k equals the 5th root of 0.94. So I've solved the first part of this. The exponential decay constant is the 5th root of 0.94. Quite a number, right? Then I go to part B. It says, if a solar panel is initially capable of producing 500 watts of power, how long will it take before the solar panel is only able to produce 200 watts of power? So when I'm reading that question, I see it is initially able to produce 500. That sounds like a start value to me, which, remember, my start value is A. It says, how long will it take before the solar panel is only able to produce 200 watts. That sounds like an ending value to me, okay, or the amount left. So this, my end value, is going to end up being my y value. Now the question says, how long? So if I'm thinking how long, I'm thinking time. So it sounds to me like I don't know my time value. I don't know my x. So I'm going to take my equation that I started with. Okay, I started with this equation right here, but now I know what my k value is. So I'm going to look at my equation. Let me erase some stuff here. I'm going to look at my equation of y equals a times, I now know my k value is the 5th root of 0.94 to the x power. And we just said we know what our a is, we know what our y is. And I'm going to plug those in. I'm going to have my y value, it's ending with 200. My start value was 500. And then I've got the 5th root of 0.94 to the x power. Okay? Now my goal is with this to get x by itself. If you guys remember, if you've got an x hanging out up there, the only way you're going to be able to get that x down is you're going to have to hit it with a log. Okay? So we're going to have to use our logarithm. But before I can use my logarithm, I've got to get that base, so the base is the only thing there. So the first thing I've got to do is I've got to divide by 500. Okay? Which when I divide by 500, that ends up giving me a 2/5. 200 divided by 500 gives me 2/5 equals a 5th root of 0.94 to the x power. Okay? Now I've got to get x by itself. And if we remember how our logarithms work, I'm going to have to hit both sides with the same logarithm. And the base of this logarithm that I'm going to have to hit it with has to match the base of the exponential function. So this is going to be a log base, the 5th root of 0.94 of 2/5. Okay, and that equals the 5th root, equals log base, the 5th root of 0.94 of our 5th root, of 0.94 to the x power. Okay? So what ends up happening here, I know that's hard to read, but what ends up happening, this log cancels this base here. So I'm left with x equals log, and then our crazy base that we came up with here, of 2/5 equals x. Okay? Now, I promised you guys when you take your final, it's not going to be this hard. Okay? This is a little ridiculous. It's not going to be this hard. But in order to solve this, we're going to have to use our change of base formula. Okay? Our change of base formula says that if I have a log of some crazy base, I can rewrite it using my log button on my calculator or my ln. Either one works. So for this one, I'd take a log of 2/5, and then I'm going to take a log of the 5th root of 0.94. Okay? And if you plug that in your calculator and divide it, that will give you your answer. I promise the one on your final won't be this crazy. Okay? When you plug that in your calculator, you end up getting an x equals 74.0. So 74 years is our answer. Okay? I promise you guys, follow through on that. You've got another example to practice, and we will work on those more. Okay? Those can be very tricky. I'll show you guys your change of base formula and all that stuff. I think I may be able to get the last problem done in about 3 minutes. Okay? You may have to put me on slow-mo so you can hear everything. Do it. Okay? I have 100 coins, all of which are either quarters or dimes. The total value of all these coins is 196. The first thing you have to do is you have to come up with 2 equations. Okay? With these 2 equations, I'm going to assign Q for quarters and D for dimes. Okay? So the first equation that I can come up with here, gosh dang it, computer's not working. First one that I can come up with is, I know that I have 100 coins. So that means my quarters plus my dimes have to equal 100. So this equation right here is just for my total number of coins. Q is my number of quarters. D is my number of dimes. I know that there are 100 coins. So Q plus D must equal 100. My second equation I'm going to use involves the money, 196. Well, how much is a quarter worth? A quarter is worth 25 cents. Plus, a dime is worth 10 cents. And I know that in total, if I add all those up together, 0.25Q plus 0.1D, it will equal $196. The second part of this question says, solve the system of equations to determine how many dimes I have and how many quarters I have. So we've got a systems of equations up here. I need to eliminate something. So I'm going to take a negative 0.25 times my top equation. And when I do that, I end up with negative 0.25Q plus negative 0.25D equals negative 0.25 times 100 gives me negative 25. And then down below, I've got my 0.25Q plus 0.1D equals 196. Okay, now I need to add these up together. My Q's will cancel. Negative 0.25 and 0.1 gives me a negative 0.15. D equals 196. 196 minus 25 gives me 171. Okay, and I need to take then 171 divided by 0.15. When I divide that by 0.15, I have messed up somewhere. Okay, so I guess we're going to make another video because I went too fast. I do not see what I did. Okay, check into the next video because I did something wrong. Sorry, guys.